Welcome back to my messy workbench. And today we're gonna build again a common mode choke. And from the same plan here, this one is for a friend that is trying to get he's getting RF down the power lines, and I was wondering if that would help him to have a common mode choke between the antenna and his transceiver. And so I'm just gonna build one. So we have the 31 core, the FT240. We have some PTFE insulated wires, that is copper wires with tin covered. And the plan here is by Delta Golf 0 Sierra Alpha, and the plan here is in the German language. So he was saying that this common mode choke is the 50 ohms to 50 ohms, and it should handle up to 800 watts, and the ones that I've built have been able to hold up 800 watts just fine. I was running 800 watts on single sideband without any problems so far. So I'm gonna build this one. Probably the usage for that common mode choke will be much below 800 watts, maybe not even 100 watts. But that shouldn't matter too much. Besides that, you probably could go with a smaller core. So right now we're gonna measure out the wires. We need, so right here it says, where are we? Those are just the details. So 144 centimeters. And this time I probably want to leave a little bit more than 144, because before it was slightly short for me to hook it up. So let's measure this out. So that is 70 centimeters. Oh, I'm going to get a little tangled up here. I need to do this here first nicer. Okay, the moral of the story is don't do this here, because it's totally messed up now, both the green and the red one. Do. Tell you the truth, I'm making it worse right now. Okay, let's measure out 100. Right there. Oops. That was 101, I think. Once more. 100. And go 155 this time. Oh, shoot. I needed to read down there. 72 centimeters long, two of them. So I just have to cut them in half here. Let me try this here. Hopefully I didn't mess it up too badly. Yeah, that should be fine. Let's fold it across. Let's cut it right there. Let's measure it out, how much we have. Okay, me not reading the instructions. So now I have 78 millimeters, which is, for the American friends here, it's 30.5 inches. And we do the same thing with the green one. Alright, that seems much more reasonable. So we have here our 4 wires. Then we go ahead and the small ones are good. Put 2 cable tiles on to hold the wires in place. Actually, we're just working on one side right now, so let's forget about that. And so we have about 3 centimeters leftovers on 72, so let's say let's go with this here. So they said 72 and I went, what did I went? Let's figure this out again. I went how much longer? 72, I went 78. So that's 6 centimeters longer, so we have 6 centimeters on each side. Should have just fine. Okay, so that should be it. So we have 6 centimeters left over. Probably should have gone longer. We'll survive. And now we just go and do our turns. So the key on those ones is to make them nice and tight without pulling out the wire. Oops. There. This one around. So the other thing is we do 12 windings. So each time it goes through is one winding. So we did 1. So if you count right here, you would see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, 12 right there. This one we missed. So right, 1, 2. So we have 2 windings already here. Let's do a few more. Yeah, let's tighten it up first. Not to cross them. So let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Eleven, 12. Ah. Double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now we put on the cable tie just so it doesn't open up again. And we need to clean this up here. So that looks good. We're gonna space them out nicer later on, but we're gonna mess up if we're gonna do the other side here anyway. So let's just continue on here. So putting the starting loop in. Get ready the last one. And so we want to kind of go the same way as before. So come over from the top. Kind of want to leave them on the same length here. I like this length. This is a little short for my taste. Should have made it longer. Oh well. Let's see how badly we screwed up. Let's try to make this a bit tighter. Tighter the better. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For some strange reason, I automatically always stop at 10. Make them tight. That's 12 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. We're good. Now, cable tie. Let's keep them the same way, so it looks halfway decent. And now I kind of messed. Came loose here. Let's pull that out again so we can tighten this up. Good, good. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12. So it needs to come through here. Here and there. No. Perfect. So now we can spread them out a little bit. Yeah. Not too horribly good. So the next thing is we're gonna put that in a box and put connectors on. So let me pause that and get those parts. So we're gonna use these UHF connectors. Since that's not for my station, I would go for N connectors. I've been trying to do as much N connectors as possible, so I don't have actually that many UHF connectors anymore around. But I have these ones, fancy silver lined ones even. So that's the electrical box that we have. You just drop that in, put the connectors on there, and we're done. So what we now have to figure out is just to drill those holes in. So for that we need to get them. Take a marker. So go somewhere like that. Would be something around there. What would that be? Close to 12 millimeters there. Actually, that doesn't help us at all. we need the center. So let's figure out the center. So the whole thing, we could go on half it, but just gonna eyeball it to where I would like it. So that's 25 millimeters would be right there. I like 25 millimeters. So we're gonna mark it. Good. Perfect. And we're gonna mark this. Perfect. Now we need to find the center right here. That's a little trickier. So what we do is, let's measure the whole thing. Is 11 millimeter and a little bit more. And not millimeter, 11 centimeter. Not 11 centimeters, it would be 10 centimeters and 1 millimeter. So let's go down to 5 centimeters, 50 millimeters. And if you just mark it like that and like, yeah. So 51 millimeters. That would get us here and here. Let's mark this and mark that. So we have two marks there, and we just eyeball where the center is and put our dot there. Oh yeah. Flip that around. Make the same thing here. Mark here. Mark there. Go to the center. Those two. Put a hole there. So the next thing is we need to go to the bolt press and put the hole in. Once we've done that, we can put the two holes on the sides. And yeah, we just take 2 screws to screw that on. We don't need to go heavy duty and 4 screws on that one. Okay, see you up in the other place. Welcome to my other messy workbench here. So we are measuring that little gap here, and that is 15 point something millimeters. Let me see if you really want to know. It's 15.2. So we can go bigger, no problem. I have this 5/8 inch bit, which is 15.9, and that would work just perfect. The bit is a little bit huge, so let's go ahead and pre-drill this. Let's just use that bit that's right here. No point changing this out. Let's lower that guy to just a perfect height, something like this, yeah. And power. Yeah, this time we have power. Not quite that good here. Oh yeah. Oh, nice and quick. have two options. Either hold it tighter or use your eyes. Should we do it the proper way? Yeah, probably. So the problem that we encounter here is we at the lowest speed we can go, and it's a little bit high. Dang it. Alright. Lesson learned. We went too high and too big with the drill bit. So let's go grab a different drill bit that's not quite as extreme. I probably have to step now quite a bit between the bits. Yep. Let's go with that one. And something like yeah. I just went a little bit too aggressive, I think, on the bits. The problem now is that I have that bump there, and it just likes to grab on. The whole thing around. And damn it, I'm hurting myself today. So that's clean that before I rest. That didn't help too much. The other side to do too, so let's do that one. Probably should have gone first with the other one. Oh well, let's see if we can do this. Perfect! Not really. I am very aggressive here with the sizes apparently. This here is a lesson on how not to drill something, apparently. Alright, this does not work. I think we should be using this thing instead. Let's see. Once I know which way to turn this thing. Thing is just spinning too fast. Yeah, that's not great at all. Me not like. Eventually I figured out which way to turn this. Let's not much up here. Put that tight. There we go. Allow that bit. There we go. Stuck hanging there. That causes problems. That's going to cause problems again with the other bit. Which sucks. Because now we are back to the monster bit. Get that bit off. So we have two hooks right there. Ah, beautiful. Much better. Alright. How does this look? Yep, works perfect. We just have to take the edges off. So right here, we scrape the edges off. You could use a file, whatever you have. But you want to make that nice and round. The inside edges would be nice too, but that's extremely hard. You can get in there. So that was a lesson of how to do a shitty job drilling. the progress. Now the next thing is we need to put 2 holes right next to it. Let's make the holes about the same size as these here, which is 1, 2, 3 and a half, a 3.5 bit. So I'm placing that in, holding that somewhat tight and correctly, and punch the markers in the center here. One here, and the other one there. So, same thing on the other side. Line it up. And the other side. Perfecto. Let me get a 3.5 inch bit, millimeter bit. Should be one of those, if that's it, probably not. That's a 4-1. Oops. The lid was on wrong. 3.5 right there. Ooh, that's looks perfect. Okay. Get that guy off. Put that one in. Long way again. Living on the edge. Let's see. Lines. Put it easily. Good enough for me. Perfect. So we go in here and we'll go down, put the screws in and sort those things up. Okay, we're back here. So I found out that the 12mm long M3 screws look like a good match. So I'm just gonna put a screw right in there. I'm gonna put a washer on the inside. And then a nylon lock nut on top of that. So what wrench do I need for these guys? Nope, that's too big. A 5 I'm confused here. 5 is too small, 7 is too big, 6 is too big. Houston, I have a problem. This one is definitely too big. What the heck? Five, 6. Five is too small. 6 is too large. Oh yeah, maybe I need something else here. Hold on. Oh boy, this is slightly embarrassing. So my set has a 5.5 and I put it somewhere. Not here. So let's do the hillbilly way. Assembling stuff here. Oh, I should have made that box clean first. Let's do that before I assemble that. Because that box got messed up when I was drilling. So let me clean that up. Oh yeah, clean that up now. Now we are ready, maybe, to put that together. So, M3, 12mm long, a washer, and a nylon nut. And then we tighten this whole thing. Maybe. God, this thing here does not work. Real tools are nice. This is a nightmare. Alright, let's make that nice and tight. Oh, maybe not tight. Let's see if that was a mistake. So you have to get... No, it's still fine. We can get that in. Alright, let's do the same thing on the other side. Screw, washer, nut, maybe I can get this out. Okay. So now we have them nicely together. Ah, did put that in wrong. Upside down. This one is right. So I can solder that nicely. I want to change this, otherwise I'm gonna have a pain soldering that. I was paying attention before, but now it's not before, and before didn't count. Let's take that out again. Did I mention that having a proper wrench is nice? I know I'm gonna find it as soon as I'm done here. Okay, so now we have this nicely on the top side. Oh, there. We have it nicely on the top side. So we have screw right here, washer, nylon nut, the opening so we can solder it. The other screw I haven't put in yet because I want to put that underneath the screw, and that's for the ground. And so, do we need to trim this wire? We actually have plenty of wire there. We theoretically could trim that. Wow. The other side, I'm not the happiest guy of trimming stuff. In case we want to redo something. So let's take those guys off. So we are putting this. Let's read through it. So, two 72 centimeters long wires, put around 12 windings with 3 centimeters long ends. We did that. Put the cable ties on, put it in, start winding, blah blah blah, blah blah blah, blah blah blah. So we need to make sure that none of them are crossed. They all look good. This one needs to be a little tighter here. And then we connect the same colors to each other. So again, how short do we want to make that? Do we want to shorten that bit? We need to turn on that soldering iron here. Alright, let's heat that thing up and take off the insulation here. Whoa. That sucked. I didn't like that. Let me grab better strippers. Alright, got these strippers here. Good old manual strippers. Now the insulation is a little vacked up on this one. How do we do this? Put them on a line here. Make a little mark here. Now we can push it away. I want to have them about the same length. A little bit too careful because I don't want to hurt the wires themselves. Okay, that's good. Twist them a little together. Let's solder them together before we start on the next one. So here we have the solder. Anybody tell you a nice, clean, organized workbench is nice? It's also a good indicator that you're probably doing a much more cleanup than work. Oh boy. Yeah, not too bad. Actually, I kind of like this length. Let's go right here, do the same thing on. To tell you the truth, it needs to be a little bit longer because this is the side. So let's make this one somewhere around longer, I said. Here. Nearly perfect. So what I do is I normally use the correct size to cut the insulation carefully, then go up one size and pull it off, just to avoid hurting the strands of wires. This is a fairly nice I should have crimped that first instead of what I'm doing here. Yeah, crap. Hindsight. Okay, we're in here. Let's go ahead and cut this down a bit. So we have put right there where we want to cut that. Shove that in, perfect. And that there, and crimp. Yep, perfect. Now normally I have a piece of wood board that I put underneath there, but today is the day of not finding stuff, so let's use the cardboard here and just do a nice sort of job right here on that crimpy thingy. 1, 2, 3, 4, 5, 6. Good. And that's done. So if you go ahead and drop that in. Yeah. Do the same thing on the other side. So the two red ones together. Let's start on those ones since they're nice together already. So we wanna say right there also. And this guy. Perfecto. Throw them together a little bit. And oh, we're gonna cut off the top anyway, so let's not go too crazy on that. On this guy, mark. Nope, didn't get the shield insulation totally. There's no shield. No shield on that guy. There we go. Perfecto. So instead of soldering it, let's first crimp it. Might be nicer. Now the question is, should I cut it to length or should I cut it to length later? Let's see if we can do this. Wow, that's a nice mess. This is a really nice wire, by the way. A tinned copper wire. Oh, okay, let's crimp that. It looks nice. That crimp is probably better than the other one. So let's go ahead and solder that on because we can. No real other reason. With the other one, the problem is if you solder it, the wires together, crimp it and then solder it again. Now the crimp might actually be weak. And you don't want to crimp it now because then you break the solder part again. So you're kind of stuck there. So now measure the depth of one of those is about that much. Okay. So we go ahead and cut that off. I really need a better cutters. Those are not the right cutters for this kind of job. Let's put it this way in. Okay. Actually, we need to put it that way in. Then we go in and drop that. Can you see that? Oh yeah, you can see it, I think. So stuck it in the hole. Take our solder iron, heat the whole thing up. Do feel free to use a bigger tip than I do here. Add a little bit of solder just so we transfer the heat better. Probably should have switched tips out. I need to switch the tips out, which is always fun. Switching tips out on a hot soldering iron. No, don't unscrew it there. We need the tip. There we go. Because that is hot and we're always lazy and don't want to wait till it's cooled off. I'm gonna use the monster tip here. Oops. That part is still hot, while the tip is not hot. And we screw the whole thing on again. Don't do as I do. Turn this on and let it heat up. While we're there, we can move that tip out of the way. Okay, that should work much faster here and better. At least that's the idea. Okay, the tip should be now at 650. Let's see. Ooh. Awesome. And let's see if we can heat that up. Yeah, that looks much better. So now we shove this core somehow further back in. Put that guy over in here somehow like this. A little bit of swearing, perfect. We're in and we solder that guy. Definitely want to make sure you have a good heat transfer so it's like a well done soldering spot. Yeah, looks okay. The good part about this wire is it's temperature resistant. Oh man, see here some problems right there. These are coming out, so we need to push that down again, because that is not so great. So grab the wires, push them down, and make a decent coil there. Yeah, there, this looks somewhat okay. Now we go ahead and grab our screw here. And put the shielding on. Do we? Oh, we have a washer, but do we actually want a washer there? Nah. We have. We don't need a washer here. That's kind of silly to put a washer there. Maybe it's not silly, because that gets stuck into the plastic. Change of heart. We put the washer there, then we put the cable on it, the nut, and our awesome wrench. And we tighten that up if we can. There we go. So the same thing on the other side. I'd like to turn this. Yep. Let's get the iron out of the way. So we can find the screw again. Washer, wire, screw this whole thing together. This needs to come out. There we go. Now, how does it look? Well, let's find out. I'm gonna clear off this area here, and then we hook it up to a spectrum analyzer and see if that does what it should do. You also can do some SWR checking if you wanted to. Not too worried about that, because that's gonna be on par, I'm fairly sure. Okay, I made a little bit more room here, so we can go to the spectrum analyzer. Let's go grab some wires here. This one and that one, maybe. And first we want to calibrate it, so let's put on our straight through connector, go in and frequency, we want to go from 1.9, 1. Let's say 1.8, 1.8 megahertz is that. All the way to, let's say we want to go 6 meters for sure. So let's go 54 megahertz. 55 megahertz. So 1.8 megahertz starting. Eventually I figured it out. Click on start first. 1.8 megahertz. So we're starting, and stopping frequency is 55 megahertz. So we are over there. We turn on the tracking generator, and we normalize it. So we are right on top, 0 decibel. Unless I'm wiggling there. So now we're gonna put that in here, and we get 0 decibel because that's the normal way you do antennas. So that's perfect. However, we want to simulate common mode current. So there we need to change something. And what we need to do is we ran a signal through one side but not the other side. So let's undo this here. So we need to generate some current, a common mode current. And for that, I'm gonna grab this cable here, hook that up. Another one of those cables. Hook this up. So our signal goes straight through. Yeah, what we first need to do is calibrate that again. That's a different wire, so we need to do some calibration. Let's get this wire out of the way. And go ahead and click on normalize. There. So now we are perfectly fine. So what happens is this goes along the shield and not on the center conductor. Is that easier to hook up there? That does not look too great. Yeah, you're great. Yeah, we want that all the way down. That looks actually pretty horrible. What did we do wrong there? Probably should have tested it out before putting it in. All that hard work. Let me grab the other one just to do a reference check again. because that does not look great. Okay, I brought here out fan dipole of a balloon that I created before, and I figured out what the problem was. I was leaving the center contactor and was using the shield. I shouldn't have done that. I need to use the center conductor for the signal. That carries the signal. So on here, this side is the shield part that goes to the green, and there's the shield. So you see right there, it's a pretty decent HF attenuation. So, but we are not interested in that one, so let's get rid of this here and go back to our box. So again, the issue there was, if you look at this, first of all, we are nicely calibrated, all of them together. So if I take the shield of our tracking generator, that doesn't do the signal. The signal comes on the center conductor, and that was my fault here. So if you connect that, now we get a nice 30 dB attenuation in it. So if we go ahead and, for example, right in here, connect, then actually see here an attenuation between, let's go on the marker and move around there. So we definitely see an attenuation there just from the, oh wait, right there. I'm connecting again on the wrong place. The attenuation came from going in the center conductor. I need to go shield to shield. So right there. So shield to shield, there's nice flat, and if you go on to the shield on the other side, we have our 30 decibel attenuation. If we connect them together, we don't have that attenuation. So again, if you go here, shield to center conductor to center conductor, let's just connect them inside, it's easier. So if you go center conductor to center conductor here, we have a 30 decibel attenuation. If you now take these connectors to the shield, now we don't get any attenuation. That's exactly what we want. So 2 thumbs up. It works fine if we do the right measurements. So let's go ahead and take that out. If you wanted to, we can double check an SWR measurement on that. Yeah, let me do that. I'm gonna grab the SWR meter and we do an SWR measurement. Okay, for the SWR measurement, I have the common mode choke right here and the wire going out to my dummy load, 50 ohm. So we're gonna go ahead and choose 160 meters and scan it, and that looks, oh, there's some jumpies. Let's do that again. Must be something loose there on the connectors that I tightened. Okay, so let's go to 80 meters. So still looks good. 40 meters. Tiny bit there. 30 meters. $20 meters. Yeah, 20 meters is definitely not the best. And 17 meters. $15. Oops. Don't type in 15. $12. And 10. $1.2 on the high ones. So let's just for fun go up to all. So right there's our details. Let's go to frequency. Zero 54 and check the SWR here. So there we have 1.3. So yeah, not too bad. I mean, the core is designed for HF, so definitely on 20 meters and higher, it's not too surprising that it goes up. So that's definitely a success, I would say, here on the common mode jerk. Now the question is, will that resolve the issue that my friend has, that where the RF goes down through the radio into the power line and trips the power line breaker? And there's only one way to find that out. This project was a nice quick project. Things that went wrong, obviously hooking up the measurement equipment and the drilling. That kind of gave me a few hours there. So don't drill like I do, apparently. Otherwise, the project is quite easy to do. Quick one. So have a good one. See you next time.